I'm behind. The 8 for hydrogen, you multiply 4 and 2, right?
Yep. Because this is just like that there. That's like saying I have H2, 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 and H2. So I have 8 hydrogens on.
Yep.
Okay?
Yep.
All right, this is going to take me a minute to write because I'm going to try to write it legibly. It might take longer than that if it keeps doing that. Y'all don't even know how much effort that took for me to write it that well. What number? Well, you gotta look at the formulas and figure it out. Do what?
Gotta remember the formula.
You gotta know the formulas, right? That's what chapter 4 was about, right? See, that's why we skipped chapter 5 and went straight to this, because I didn't want to do that chapter in between. All right, look, some keys here. When you see this, what does that mean? When you see this ending,
It's gonna be a polyatomic ion.
polyatomic ion. Okay? So, silver nitrate, AgNO3. 2 is nitrite. And it's aqueous, AQ. Reacts with NaCl, and it is aqueous. To produce silver chloride, +1 -1, right? Solid, S. Plus sodium is +1, nitrate is -1, so it looks like that. Now, let's balance it. I'm going to tell you what.
It has to be balanced.
It always has to be balanced.
Okay.
You can't write it without balancing it. Now you got to go balance it. Or you got to verify it's balanced. I have silver, and I'm going to show you how we're going to do this. This is coming up the slide. When you have a polyatomic ion that appears on both sides of the equation, like that, like nitrate does, balance it as nitrate. Okay?
I was wondering that.
That'll make your life easier. But it has to be exactly the same on both sides. Okay? It has to
Do
be
that with
NO3.
water too, H2O? Just consider it one.
You want to receive water on both sides, because that means it didn't do anything. What else do I have? I have sodium, and I have chloride. Silver on the reactant side. How many silvers do I have on the reactant side?
One.
And on the product side? How many nitrates on the reactant side? And on the product side? Sodium's on the reactant? On the product? Chloride's on the reactant? On the product? Does this column equal this column?
Yes.
It's Allison, right? Allison's like, well, I think I did something wrong because I should have to balance it. Why do you have to do something wrong? You can be like that. It's okay. So it's balanced as it's written, just like this. Okay?
Is that common or is it more?
No, it's more common that you have to do something to it. Yeah. We're okay? Do it? There'll be plenty of the homework for you to do. We just did
You
two.
won't be there.
I will. I'm just in an email or an office visit away.
We emailed you last week and you were
I can't live here. Well, I could, but I'm not going to. All right, here's a reaction for you that we're going to balance. Why don't y'all balance this one right here? Come on.
You have to change something though.
I'm going to leave the states off just to make it easier to balance so we can see it. Okay, let's make our list. What do we have? We have sodium, we have phosphate, we have magnesium, and we have chloride. Okay, we ready? How many sodiums do we have on the reactant side?
3.
And on the product side, right now, how many do I have?
1.
But you can put 3.
So I can put a 3 here, and then I'll fix that. Okay? Phosphates. 1 here,
2.
2 here. Right? 2 is a subscript. So I gotta fix that, don't I?
Yes.
So I'm gonna put a 2 here. So that fixes that. But it messed this up, didn't it?
Makes 6.
That made that a 6. So how am I gonna fix that? I need 6 sodiums on this side. I'm gonna mark that out and I'm gonna put a 6 here. Magnesium, 1, and on this side, okay. What do I put here?
3.
3. Chlorides, on the reactant side,
6.
now there's 6, right? 3 times 2 gives me 6. And on the product side,
6.
6. Note, I did not change any of the formulas. I'm not allowed to change subscripts. And I didn't put anything in the middle anywhere, did I?
Nope.
Only use coefficients in front of the formula. Okay? Now, was this one a pain to do? A little bit, yeah. Because you had to go back and forth a couple of times to make it balanced, didn't you? Okay? Students get frustrated because they try to jump to the end, doing one step at a time, and you can all do these. It's not like we're doing differential calculus. We're adding up how many of each we have. Everybody in here can add. I know you can. You can count, right? Just go from one side to the other and count how many you have. When it doesn't match, fix it. Make it count. Make it work. Now, somebody in the other class said they had come up with something like, oh, let's do it in blue, I guess. They had come up with 4, 6, 12, and 2. Is there anything wrong with that? The answer is yes. All of these are divisible by 2. You have to reduce it down to the smallest that you can. The answer should be 2, 3, 6, and 1. Okay? Make sense? Okay.
Well, except for, you've got 6 on,
Where? What?
right there, 6.
Here?
Uh-huh.
Yeah, but those go, there are 6, the coefficients are 2, 3, 6, and 1.
Okay, I gotcha.
But
3.
there's 6 sodiums, right?
Right,
Yeah.
right. What's the purple numbers on top, what's that?
I said, somebody in the other class had told me, well, I have 4, 6, 12, and 2. And I said, well, that's wrong. You can't have that. You have to reduce it. Okay?